Hello, eighth graders. I realize this is probably going to be a long video, but it's very important. This is a challenging section. And so I want you guys to not only have printed out these problems and work them with me, but you'll probably want to go back and watch this video and look at these problems at least one more time, just to kind of get a good understanding of this material. All right, so I'm trying to find my pen, never prepared. All right, so this whole unit is called systems of equations. All right, so basically we have the last couple of units, we've looked at linear equations and we've graphed them and we've solved them for y. And this unit is putting all that together. And this time, when we have a system of equations, that just means you have at least two equations that have to work together to figure out if there's a solution or not. So a system of equations is two or more equations working together. The solution to a system of equations is always the point where two lines intersect on a coordinate plane. So for example, you have a line, this top line right here, we'll call it letter A, has a negative slope, it's going down and to the right. And then line B has a positive slope, it's going up and to the right. And those two lines intersect here at 3, 3. So you would say the solution to this system of equations is 3, 3. That is the solution. In other words, if we had these two equations written out, and if we didn't have a graph, when x is 3 and y is 3, it would make those two equations equal to each other. Okay, so anytime you have two different situations that depend on each other for a solution, that's when you would create a system of equations. For example, let's look at this first problem right here. Farmer Brown has 18 animals, which are cows and chickens. Okay, the animals have a total of 52 legs. How many cows and how many chickens does Farmer Brown have? All right, so we have two bits of information that we have to consider when answering this question. The first thing we have to consider is the total number of animals Farmer Brown has. And the second thing we need to consider is the number of legs that they have. All right, so two different sets of information, right? So the first thing I'm going to do is create an equation that represents the number of animals. So let me use the red that I had. So for my animals, I'm going to let x equal cows and y equal chickens. Okay. So the number of cows plus the number of chickens is equal to how many? Well, 18. Well, like I said, the second equation has to deal with how many legs those animals have. So how many legs do cows have? They have 4, right? So whatever the number of cows I have, I would multiply that number times 4, plus how many legs do chickens have? 2 each. So however many chickens I have, I would have to multiply that number of chickens by 2, and that gives me a total of 52 legs. Right? So I could graph these two equations and see where they intersect to get my answer. I could do that. Or I could take my first equation and I could solve it for y by subtracting x from both sides. So I would have y equals 18 minus x. Right? I solved it for y by getting rid of this positive x by subtracting x from both sides. And then since y is equal to this, I could substitute for that letter y in the second equation. I could substitute the value of y, which is 18 minus x, and bring down the rest of the equation. Then I could use the distributive property. So 2 times 18 is 36, and 2 times negative x is negative 2x. Equals 52. I can combine like terms. 4x minus 2x is 2x, plus 36 equals 52. And then to solve for x, I'm going to subtract 36 from both sides. I'm just solving a two-step equation right now. So 52, let's see, 52 minus 36 is 16. And then the last thing I would do is divide both sides by 2. And so it says that x is equal to 8. Well, what are x's? What did the x represent? Well, I said right here that cows is x. That means I have 8 cows. So if I have 8 cows plus y equals 18, y has to be equal to 10, doesn't it? So 8 cows plus 10 chickens is 18 animals. I could check the number of legs by saying, well, 4 times 8 is 32. I have 32 cow legs. And 2 times 10 is 20. So I have 20 chicken legs for a total of 52 legs, which is what it says. So I realized that's a lot of work, but I needed both of these equations to help me figure out the answer to that question, right? All right, let's look at another one. This says that Jack has a total of 20 bills, and those bills are $1 bills and $5 bills. He has a total of $40. How many $1 bills does he have, and how many $5 bills does Jack have? Once again, we have two different things. We have let X represent $1 bills, and Y is going to equal the number of $5 bills. Whoops, I meant to put a dollar sign, not a number. So we know that he has a total of 20 bills, which are $1 bills and $5 bills, right? Well, we don't know how many $1 bills he has, but we do know that for every dollar bill, it equals 1 times the number of bills. And then the $5 bills, however many we'd have, we would multiply that number by 5 because $5 bills are worth $5 to get a total of $40, right? Once again, we are going to solve for, this time let's solve for X. Well, the only way to get rid of plus y is to subtract y from both sides. So X is equal to 20 minus y. I'm going to erase this because I don't want us to get confused. That's our original equation. And then the other equation has to do with the amount of money we have, all right? So I'm going to substitute this value for X into this equation. Well, if I use the distributive property, 1 times 20 minus X is 20 minus X, right? So I'm substituting, instead of writing X, I'm writing 20 minus, I meant to say Y, 20 minus Y. So that's what the value of X is right there. And then I'm going to bring down the rest of the equation. So now I'm going to combine like terms. I have negative 1y plus 5y. So negative 1 plus 5 is 4y, positive 4y. So I want to solve for y. So I would subtract 20 from both sides. So I would bring down my 4y equals 20, divide both sides by 4, and that tells me that y equals 5. Well, what is y? Y is the number of $5 bills. So I have 5 of those, 5 $5 bills. And what plus 5 equals 20? What plus 5 equals 20? That has to be 15. So there's my 20 bills, 5 and 15. And then I want to check and see if I have the right amount of money. So 15 times 1 is $15 in $1 bills. And 5 times 5 is $25 in $5 bills, which gives me a total of $40. So I know I'm right. So once again, you see another example of two different situations influencing determining my answer, which is we need a system of equations to figure out the answer, okay? All right, y'all hang in there with me, okay? All right, so the first kind of question I want to give you is this one. It says, is the point 6, 0 a solution to the following system? Well, these coordinates are always written in the same way, in the same format. The first number goes with the x-axis and the second number goes with the y-axis. So instead of x, I'm going to substitute 6. Instead of y, I'm going to substitute 0. So I'm going to say 2 times 0. And I want to say, is this true? Well, 2 times 0 is 0. And is 6 minus 0 6? Yes. So the answer to the whole thing might be yes, but we must have two yeses. We have to have two yeses. So we're going to take our second equation. I'm going to write it over here. Once again, I'm going to substitute 6 for x and 2 for 0. Now 2 times 0 is 0. Now it says that 6 minus 0 is -1. Is that true? No, it does not equal -1. That's not true. So in order for the answer to the entire question, I have to have two yeses. And since I don't have two yeses, the overall answer is no. That is not a solution to that system of equations. All right, let's do another one. Is the point 5, 6 a solution to the following system? All right, so we're going to take our first equation. We're going to substitute 5 for x and 6 for y, and I get a true statement. 11 is equal to 11, yes. Now I'm going to take my second equation. I'm going to substitute 5 for x and 6 for y and see what I get. So 4 times 5 is 20 minus 30, and 20 minus 30 is 10. Yes. So the answer to the overall question is yes. This is a solution to the following system because we must have two yeses. All right, so you try it. So I've given you 2, 3 to do on your own. So I want you to pause the video and I want you to do these on your own and then come back and check your answers. All right, so we're going to take each of these. So once again, x is -3, y is -4. So for 4, so let me write the equation first of all. So I have -4 is equal to 2 times -3 plus 2. So 2 times -3 is -6, and -6 plus 2 is -4. So I get a yes. And then my second equation, y is -4, x is -3 minus 1. Is that true? Yes, it is. So hopefully for the first one on this page, you got a yes. Good. All right, what about the next one? So y equals 3x minus 2. Here's our x, here's our y. So -8 is equal to 3 times -2 minus 2. So -8 is equal to -6 minus 2. So I get a yes. And then I'm going to have -x minus 6. So -8 is equal to the opposite of -2. This means the opposite of x. X is -2. So the opposite of -2 is +2. So that means that this is a no, isn't it? So the answer to the whole question is no. So did you guys get those? I hope so. All right, let's do these. So we have x plus y equals 7. X is 2 and y is 5. So 2 plus 5 is 7. Yes, that's true. And then I have my second one. So 3 times 2 minus 5 is 1. 6 minus 5 is 1. That is true. So the answer to the question is yes. All right, so when we have a system of equations, we can have 3 different outcomes. The first outcome is that there is one solution. So when you end up with one solution, that is where if these 2 lines were graphed on a coordinate plane, those 2 lines would intersect. So for example, we just looked at this. Did you notice that equation is the same as, was it this one? I think it was this one. We ended up getting no because I said the solution is -2, -8. So it's the exact same equations, but they don't intersect at -2, -8. That's why the answer was no. You understand? Where they intersect at is -1, -1, -5. So if I plugged in these values for x and y, I would get 2 true statements. You understand? The other one was no, because when we plugged in those numbers, -2, -8, into our equations, we didn't get 2 correct answers. We only got 1. So that's why they didn't intersect at that point I gave you originally, but they do intersect at -1, -5. So if I plugged in -5 right here, and then I multiplied 3 times -1, I get -3 minus 2, which is -5. Both of them would be true if I use that solution. All right, so besides getting one solution, I could get no solutions because there are lines that exist that never intersect. What are those lines called that never intersect? Well, you guys know they're parallel lines. Parallel lines will never intersect. And we've talked about parallel lines already. The thing about two parallel lines is they have the exact same slope, right? So both of these lines have a slope of +2. The slope of both of these lines is +2. They do have different y-intersects. They must have different y-intersects, but they will always have the same slope. All right, so if you end up with two parallel lines, your answer will be there's no solution because those lines will never intersect, never. Now, besides one solution and no solutions, you could also get an infinite number of solutions, okay? So what happens here? So look at these two equations. They look different, right? The numbers are different. But if I solved for y on both of these and graphed what I got, those two lines would lie on top of each other because basically the graphs are identical. That means every single point on these two lines is a solution because they meet at they have the same points, all of them. So for example, let me show you what this would look like if I solved for y. So if I solve for y, I'm going to subtract x.
Kristen Garner, please call extension 1104. Kristen Garner, 1104.
All right, when I divide everything by 2, I end up with y equals -1/2 x plus 2. So that is the top line solved for y. Well, now I'm going to take the second line and I'm going to solve it for y by subtracting 2x from both sides. So I'd have 4y equals -2x plus 8. And now I'm going to divide every single number by 4. And guess what I get? I get the same thing because -2/4 is equal to -1/2 x. And 8 divided by 4 is +2. So do you see why these two lines lie on top of each other? They're identical. They're the same line. So basically, if you look at each of the coefficients, this is 1, this is 2, this is 4. If I can multiply all of those numbers by the same number and get the other coefficients, it's always going to be an infinite number of solutions because 1 times 2 is 2, 2 times 2 is 4, and 4 times 2 is 8. So if you see that a pattern, and we're going to look at a couple more of those examples. But first, I want you guys to figure out, don't ignore this right now. I want you guys to write the solution to both of these systems of equations on your paper. All right, so basically it's just the coordinates of where these intersect. That's it. So how would I write this coordinate? Start from the origin, go right 1, and then go up 3. So the system to this, the solution to this system of equations is 1, 3. What about this one? So if I start at the origin, I would go left 2, and then down 1. And so the solution to this system is -2, -1. All right, so now let's look at these. How many solutions do these systems have and why? Well, I don't have a graph, but look at these two lines. They're both solved for y, so I can immediately tell that both of these have the same slope and different y-intersects. If they have the same slope and different y-intersects, it means they are parallel lines. which means they have no solutions, 0. They'll never intersect, they're parallel lines. All right, let's look at this group. So this one's already solved for y. So we're going to take the second equation and we're going to solve it for y and see if there's anything they have in common, right? So we're going to solve for y by getting rid of 2x. So I'm going to bring down y equals negative 2x plus 10. So now I'm going to compare my y-intercepts and my slopes. So what do I notice about the slopes? They're the same. And what's true about the y-intercepts? They're different. So if you have same slope, different y-intercepts, S-E-C-T, that means they are parallel. And that means there are no solutions. They'll never intersect. All right, now you also will have some equations without seeing a graph that have an infinite number of solutions. So remember what I told you. If you can do something, if you see a pattern and you go, okay, wait a minute, it looks like if I multiply 1 and 2 and negative 4 by the same number, I'm going to get these numbers. What is that number? 4, right? So if I take this whole equation and I multiply it by 4, I end up with 4 times y is 4y. 4 times 2 is 8x. And 4 times negative 4 is negative 16. Okay? If you have a situation where you can multiply the entire equation by a number and get the other one, that means you have you have infinitely many solutions. Infinitely many, or you can say an infinite number of solutions. Either term is correct, all right? And here in the building, instead of writing out infinitely many solutions, we just write out IMS, infinitely many solutions. But you got to look for it though, right? They have to kind of be in the same form, or you have to turn them so that they look the same. Like here's my x plus y. So could I multiply the coefficients by the same digit? Yeah, once again, it's 4. It's just a coincidence. It's not always 4, but in this situation it is. 4 times x is 4x, 4 times y is 4y, and 4 times 2 is 8. So once again, we have an infinitely many solutions. All right, so here is an example I got from your little formative quiz. Do you see the pattern? What can I multiply all of these numbers by? 3, right? 3 times x is 3x, 3 times y is 3y, and 3 times 4 is 12. Now, every single number would have to be able to be multiplied by the same digit to get the other solution. So we have an infinitely many solutions because we see that pattern. All right, let's look at this problem right here. Line M is represented by the following equation. What is most likely the equation for line P so that the set of equations has infinitely many solutions? That means we're looking for an equation that's been multiplied. If we take this and we multiply it by the same digit, we're going to get one of these, right? Well, I know it's not the bottom one because the signs don't even match, right? We have a negative y and we have a positive y. We have a negative 1 and we have a positive 1. So I'm going to take this one off the list. Now the rest of them I see are 2 x's and 2 y's. So I'm going to try multiplying the whole equation by 2. So what's 2x? 2 times x is 2x. I just said it. What's 2 times y? Positive 2y. And what's 2 times negative 1? Negative 2. So do you see that on that list? Yep. It's letter C. These two are close, right? But no cigar. Here's a positive 2. We got negative 2. This one's a 4. And we didn't get 4 at all. So I hope that this is making sense to you guys. All right, so now it says how many solutions are there for this system of equations? Well, since the bottom one is solved for y, I'm going to go ahead and solve the first one for y. So how do we solve for y? We get rid of x by subtracting x. So basically, I have y equals negative x plus 10. So we're comparing two different equations, and what is true about these? They have different slopes. So once you see that the two lines have different slopes, you already know the answer to the question. The answer is one solution. And how do I know it's only one solution? Because with both parallel lines, they have to have the same slope, right? And an infinite number of solutions, they do have the same slope, even if they look like different numbers. So going back to this one, it looks like these two original equations have different slopes, but once I multiplied this entire equation by 2 and I saw that they are the same exact line, they really do have the same slope. Okay, I know that's confusing, but if I graphed my original equation, x plus y equals -2, if I turn this into slope-intercept form, I would also get x plus y equals -1. I think I said -2. I meant -1. If I simplified this and solved for y, the right answer down here, I would get the exact same slope and the exact same y-intercept. So if you know, okay, I can't multiply -1 and 10 by the same number to get 3 and -8, it has to be one solution. They will intersect because they don't have the same slope. It's a lot in this video, you guys. I know it is. That's why I recommend that you probably need to watch it more than once. All right, two lines, M and N, are represented by this equations right here. Which of the following options show the solution of the system of equations and explains why? So first of all, I see that they have different slopes. The next thing I want to think is, well, what if I multiply the first one by a digit, all of them by one digit, would I get what's down here in the second one? Let's say I tried a -2 because x is -2. Well, y times -2 is -2y equals x times -2 is -2x, and 3 times -2 is -6. This is not this equation, is it? Nope. So since they have different slopes, and I tried something to see if they could have the same slopes, I know there's only one solution. The slopes are different. I have one solution. So now when I look at my choices, I realize, okay, well, all of these are telling me the solution is 1, 4. The only thing I have to figure out is why 1, 4 would be a solution. So let's look at our choices. If I graph these two lines, let me erase this mess. If I ended up graphing these two lines, why would this be a solution? Is it because the point does not lie on any axis? Have we talked about a point being on either the X or Y axis only? No, I don't like that answer. All right, let's look at B. 1, 4, because one of the lines passed through the point? Is it because only one of them do? I think we could get a better answer. 1, 4, because both lines pass through that point? Well, that's got to be it, right? That is why we have a solution where they intersect, which means that point has to both lines has to pass through that point. I like C. I don't even know what D says, but I know it can't be the right answer. But let's look at it anyway. 1, 4, because the point lies between no, we haven't said anything about being right on the X or Y axes, right? So that doesn't even make sense. So C is the right answer. It's where they both intersect. All right, let's look at this one. Letter M is represented by this equation. So we have X minus Y equals 7. It says, which equation completes the system that is satisfied by the solution? So it's telling me that this is a solution to a system, and this is half the system. Well, remember that 17 is X and Y is 10. So let's just throw those numbers in, and I go, okay, well, that's true, isn't it? That is a true statement, which means one of these is going to also give me a true statement using 17 for X and Y for 10. So that's what I'm looking for. So let's check A. x plus y equals 17. Well, if x is 17 and y is 10, that definitely doesn't equal 17, does it? Nope, that's 27. All right, let's try B. 2x minus y equals 34. Well, if x is 17 minus 10 is 34, well, 2 times 17 is 34. If I subtract 10, I would get 24. So that is not true. Not true. No, no. Let's try the third one. I'm going to get rid of this one. All right, we have 2x plus y equals 44. Well, if x is 17 plus 10, I'm liking it. 2 times 17 is 34. And does 34 plus 10 equal 44? It sure does. Yep, I like it. See again, you guys. See again. And then 17 minus 10 does not equal 27. That's not true. Line Q is represented by the following equation. Which equation completes the system that is satisfied by the solution 3, 5? Okay, same type of question, right? So x is 3, 2 times 3 plus 5 is y. Well, I know that's true. 6 plus 5 is 11. So I'm trying to find out which of these is going to also be true with x equals 3 and y equals 5. So if x is 3 plus 2 times 5 is 15, is that true? 3 plus 10? Nope, that's not true. 3 plus 10 is 13. All right, let's look at this one. 3 is x, 5 is y. Is that true? 3 plus 5 equals 15? No, it equals 8. All right, what about this one? 3 plus 5 equals 8. Oh, yep. Ding, 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 ding. There's our winner. And we know that 3 minus 5 doesn't equal positive 2. It equals negative 2. So B is the best, it's the only answer. It's the correct answer. All right, so after you go through the systems of equations section, the next section is called solving systems of equations by graphing. So I gotta remind you guys how to graph. So remember, when you graph, you always start with the y-intercept. So we're going to start up here at positive 2. And then remember, our slope is rise over run. So from here, we're going to go up 3, 1, 2, 3, and right 1. 1, 2, 3, right 1. So there's oh my goodness, I'm so bad at straight lines, you guys. All right, so that's our first line. Now, you guys are doing this with me, I hope. All right, now we're going to start at positive 7, and our rise is negative 2, 1. So we're going to go down to 1, down to 1, and we see that they both go straight through this point right here. So what is the system? I'm sorry, what is the solution? Start at the origin, go right 1, up 5, right 1, up 5, and that's our answer. All right, now the second one is already solved for y intercept form. So let's solve the first equation for y. So we're going to write 3x minus y is 9. We're going to subtract 3x from both sides. So we bring down negative y equals negative 3x plus 9. And then we got to get rid of that negative sign by dividing every single term by negative 1. So we get, for the first one, y is equal to negative 3 divided by negative 1 is positive 3. And 9 divided by negative 1 is negative 9. Okay? All right, so that's the top one. So we're going to come way down here. The next line would be 9. So that would be my y-intersect. And then my rise is 3 and my run is 1. 1, 2, 3, 1. Oh my goodness, my pen. 1, 2, 3, 1. 1, 2, 3, 1. Ugh. All right, let's change colors. Now we're going to do positive 11. Goodness, I didn't pick the right numbers, did I? 8, 9, 10, 11. This is not a good one to do. So that would be 10, 9, down 2, right 1. I'm gonna go down to 1, 2, 1. Do it again, 1, 2, 1, 1, 2, 1. So if I made this a little bit longer, 1, 2, 3, 1. Yep. If I had made this longer, and when I draw this line, right there. That was a terrible example for me to use. I should have paid attention to my numbers. Anyway, so to get to this point, I would go right 4 up 3, right 4 up 3. Okay. And if I plug these into both equations, I would see I got 2 correct statements. All right, let's do the top one here. Thankfully, these are already solved for us and they're small numbers. So we're going to start with our y-intercept, which is -3. And then our rise is 2, our run is 1. So we're going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. We could do that all day. And then the second one, well, I don't see a y-intercept. So what must it be? Oh, it's 0. Remember? All right, so our y-intercept is 0, and then our rise is -1, and our run is +1. So we're going to go down 1, right, down 1, right 1, down 1, right 1. And I see that those two intersect right here. What is this coordinate right there? So from the origin, I go right 1, down 1, right 1, down 1. That's my solution. Oh, man. All right, I want you guys to try it. There are 2 for you guys to try, and then we'll be done, you guys. All right, let me know when you're done. Well, that's impossible. This is a video. Silly, Miss Richardson. All right, so we're going to add, hopefully you guys did this on your own. We're going to add x to both sides. So we get 2y equals 1x plus 2. Then we're going to divide everything by 2. So we get y is equal to 1 over 2x, 1 over 2x plus 2 divided by 2 is 1. So this first one, look at this. Look at this, guys. What does that mean? It means they're the same line. Let's prove it. We're going to start at +1. Our rise is 1. Our run is 2. Up 1, right 2. Up 1, right 2. Up 1, right 2. Blah, 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 blah. There's my blue one. What about the other one? Well, my y-intercept's the same. Go up 1, right 2, up 1, right 2, up 1, right 2. And guess what? My red one is the same line. So what's the answer? Infinitely many solutions. Because they not only have the same slope, they have the same y-intercept. Okay? All right, the last question says, which description best describes the solution to the following systems? Well, I've given you guys a graph, so hopefully you graph these. So I'm going to start with my y-intercept, +3. And my rise is -2, right 1, -2, right 1, -2, right 1, -2, right 1. Okay, so Nate, let me do it again. All right. 1, 2, let's see, 1, 2, 1, 1, 2. I'm just trying to make it a little bit longer. All right, that's pretty terrible. All right, and then let's do blue. I like the blue color. So we're going to start with +6. And we're going to go down 1, right 1, down 1, right 1, down 1, right 1. Well, when I do that, I notice they're going to intersect up here somewhere, aren't they? So instead of going down 1 right, I'm going to go up 1 left. Up 1 left 1. Wait a minute. So are they going to intersect? 1, 2, 1, 1, 2, 1, 1, 2. They wouldn't intersect here. It'd go 1, 1, 2, 1. They would intersect, I believe, at here, whatever this one is. All right, so anyway, let's read our choices. Line -2x plus 3 intersects the line Well, yeah. Yes, if they, I didn't even have to do all that, guys, because I didn't even read my choices. Look at letter B. This line intersects the origin. Well, it doesn't. Here's the origin. Nothing intersected the origin. That's not even true. Lines this and this intersect at the x-axis. No, they intersect way up here somewhere, even though it's hard to tell exactly what that point is. They don't intersect at the x-axis, and I can see that because I graphed them. And then it says these two lines intersect the y-axis. Well, they do both go over the y-axis, but they don't intersect there, right? That's the big word, is where those two lines intersect. So as long as you have one line that intersects the other line, that is the description of a solution. Okay? All right. All right, guys, I know that was a long video, but I encourage you to watch it another time, maybe in a day or two, and kind of let it sink in, because this is a challenging unit. But guess what? Oh, something in my eye. Sorry. It's a challenging unit, but guess what? It's the last unit of 8th grade. You'll be high schoolers soon. My babies are growing up. All right, you guys, have a great day, and I will talk to you guys soon.